Okay, so to understand half reactions, we have to look at the whole reaction again and remember what we learned last week. So the first thing to figure out this redox reaction right here is to assign oxidation numbers. So I look at this first thing, zinc, and I say, okay, what does zinc have to be to get that whole thing to add up to 0? Oh, wait, it's alone, so it's 0. So if you remember, if you're alone, you're a 0. So I always forget, and I go and I look at zinc, and I'm like, oh, zinc can be +2, +3. No, it's 0 because it's alone. All right, then on to the next one. H's are pretty much always +1. And then Cl, it's only negative choice is -1, and that works, +1, -1. So I have assigned oxidation numbers that I found at the top right corner of the table to make the whole compound add up to 0. +1 -1, that equals 0. All right, then I see H2, and I'm like, oh, +1. H is always +1. But it's alone here. It hasn't bonded. It hasn't lost electrons. It hasn't gained electrons, so it shouldn't have a charge. And plus, I want the whole thing to add up to 0, so there's not two things that are going to add up to 0, so it's just 0. When you're alone, you're a 0. Even if you're hanging out with yourself, there's two H's, you're still alone. And then this one, ZnCl. When I go to look up zinc first, it's got multiple possible charges. I think they're like +2 and +3. And then when I look at Cl, I'm like, oh, Cl, its only negative choice is -1. So zinc must be +1, right? Oh, wait, there's two of them. So two -1s makes -2. So zinc must be +2. So now that I've done this, and only now, I can decide who got oxidized and who got reduced. So I have to do these little oxidation numbers, or we can call them charges, same thing. So I'm going to go, okay, who got reduced and who got, let's see, oil rig. Who got oxidized? Oxidation is loss. Who got reduced? Reduction is gain. I also like to say ox up and reduce down as far as charge. Because when I'm looking at it this way, it's easier for me to think about whose charge went up or down rather than like, okay, who lost, who gained. I just think it's easier. So I'm going to say who got oxed up. Let's see, zinc. What did you do? You went from being 0 to +2. Okay, so your charge went up. So zinc is what got ox up. So now I know zinc is what got oxidized. Okay, so there's half of my redox reaction. That's the oxidation half of redox. And that's where half reactions are to come in a minute. I'm only going to look at one of them. All right, so the other half is the reduction. So who got reduced down? Whose charge went down? Let's see. H went from being +1 to 0. Cl went from being -1 to -1. All right, so Cl didn't do anything, but H did. So H went from being a +1 down to a 0. So it looks like it went down, went from +1 down to 0. So its charge got reduced down. So that's what got reduced. All right. So just to figure out who got oxidized, who got reduced, I had to assign all the oxidation numbers, making sure that each little compound added up to 0. If it was alone, it was already 0. Then I look at the charges. I look for who got oxidized up, whose charge went up from left to right, because I read from left to right, and whose charge got reduced down when I went from left to right. So now I know who got oxidized, who got reduced, and this is all gonna kind of culminate in like how a battery works, because in a battery, one thing gets oxidized, one thing gets reduced. So that's the kind of point of this. But now I'm gonna just work on like, since I want to say like, I guess if you're like working with batteries in that kind of industry, you need to know that one of the metals is going to get oxidized and one's going to get reduced. And you need to be able to like write that reaction. So you're going to write, if it's a redox reaction, redox, half of it is the oxidation and half of it is the reduction. So when you just write the oxidation, that's called a half reaction. Or when you just write about the reduction, that's called a half reaction. So we're just going to like write a little half reaction that only tells half the story. It says, this is what happened to the thing that got oxidized, or this is what happened to the thing that got reduced. All right. So let's do that. And just like when we balanced before, and you'd say, okay, if there's one zinc here, there can only be one zinc here. If I have two Cls here, I got to have two Cls here. Okay, I do. So just like we used to kind of balance two sides of the equation to make sure you have the same number of chlorines on one side and the same number of chlorines on the other side, we're finally now also going to make sure that we have conservation of charge. That if you have +3 on one side, you have +3 on the other side. All right, so that is new. So we're going to call that conservation of charge. So we already knew we have conservation of mass, meaning like if something's conserved, like conserving water, you don't waste it. It doesn't just disappear. So it's like mass cannot be created or destroyed. It just like moves from one form to another. Same thing with charge. Charge can't be created or destroyed. It can't appear or disappear out of nowhere. It just gets like maybe moved from here to here. So maybe the electrons left the zinc and went over to the hydrogen, but they didn't disappear. They're still accounted for. They're conserved. Okay. So that's a big part of this. And actually, even if you don't understand all this right in the half reactions, if you just know that like charge is conserved, if like, yes, I have, let's see, I have +2 over here. See this? But I also have 2 +1s over here. So I have a +1 over here and there's 2 of them. So it does end up working out that I have like the equal number of positives and negatives on either side. So that right there, that not losing of charges as you move from left to right, from the beginning to the end of the equation, that is conservation of charge. No charge is lost. If this side has a +2, this side has a +2. This side has a -1. This side has a -1, and there's 2 of each of them. So each side has -2, -2. So the charges like will always balance out, just like the number of atoms always balanced out. So we already knew conservation of mass. Now we know conservation of charge. And in the next video, I'll show you how to write a half reaction that represents that.